Welcome to How to Make a Coal-Fired Steam Engine Boiler Plant, Part 26. How to make a blower for starting a coal-fired model steam boiler. If you watched the last episode in this series, you will have noticed, or you just may have noticed, that it was a dismal failure. And the last episode was a failure for several reasons. The first one being, I didn't have one of these. This is called a steam blower. And the other reason, of course, is everything that I did, I purposely did it wrong to show how not to do it. So in this episode I'm going to show how I made a steam blower. I've had this blower for quite a long time. A few years ago a lot of them kept cropping up on eBay. Initially they were quite expensive, but they got cheaper and cheaper, and I bought 2 or 3 of them, and they make into quite neat little blowers. The 24 volt motors, which at first you think, oh, it's 24 volts, it's not going to be fast, but it's plenty fast enough with 12 volts going through it. I don't really need to go into great technical detail about how to make a blower because it's already made. I'm just making a fitting that allows me to sit it on top of the chimney, because if I sat it on top of the chimney as it is, it would fall off and damage the boiler. In order to remove the cover plate, I removed the screws, but the cover plate would not budge, and I really didn't want to brutalise it, so I thought, I know, I'll just use my ink pad. I use this ink pad quite a lot when I'm making gaskets. I use it for transferring the shape of things like cylinder covers and steam chest covers to the gasket material. This proved more difficult than I first thought because the cover plate on the blower is not flat, but after a couple of attempts I managed to get the hole positions imprinted on a piece of gasket material. I don't really need a gasket, it was just a hand, I couldn't find a piece of cardboard. So this is going to be the template that I'm going to mark out, cut out with a pair of scissors, and here I'm transferring the shape of the template to a piece of 3mm brass. I started to cut this out on the bandsaw, then I thought, no, just a minute, I'll drill it first. And here I'm using a centre drill, followed by a 3/16 twist drill to drill the holes, which with a bit of luck will be in the right place. This clip shows me using my 1-inch belt sander to just shape the parts. I know it's not good engineering, but I really find things like this very useful, very quick, and with a bit of practice you can get the shape that you want. And the other thing about using a belt sander like this is the part gets very hot indeed and burns my fingers, and I'm not going to go into any more detail about why I don't wear gloves, but I'll just say one more time because I like to know where my fingers are all of the time. Moving back now to the template, I've cut out the middle of it. And to make it perfectly round, or almost round, I'm using a small drum sander in my Minicraft drill, and then all I'm going to do with this is sit it on the piece of brass, align the holes for the screws, and draw around this as well. I frequently get messages from viewers. Some of them are okay, they're just sort of nice messages, and sometimes they're good hints and tips, and then occasionally I get messages like the one I got the other week, all in capital letters saying, "You should not hold pieces of metal in your hand when drilling, because if the drill grabs the piece of metal, it will spin round and it will cut your hand very badly." I sort of agree with the comment, but the drill bit I was using at the time on the video that he commented on was not capable of spinning the work, it was far too small. If I was using a drill bit like this of course is a stepped hole cutter, then the last thing I would do would be to hold this piece of metal in my hand. That's why I have this really poor quality cross vise in the drilling machine. And if you watch the video carefully, you will see that the hole cutter keeps stopping, and that's because I never over tighten the belts on the drilling machine. I generally do include health and safety warnings, and it's obvious that you should never hold small pieces of metal in your hand when drilling them on a drilling machine. So once again, I've escaped serious injury and I still have most of my fingers left. And here is the base plate for the bottom of the blower. What I should have done first is tested the blower. Oh yes, it works, that's a good thing. Over now to my little Boxford lathe, and all I'm doing is just cleaning up a piece of tube. I already had the tube, but it was more or less the right size, just a little bit tight. But when I try the chimney in place, it's fine. Just a little bit of shake, I don't want it to be too tight. Once sufficient steam has been raised in the boiler by using this electric blower, then I will switch over to the steam blower. So I'll have to quickly remove this, and it will be hot, so the last thing I want it to be is a tight fit. And on the subject of things being hot, it's time to silver solder these parts together. This of course is the main base, and this is the tube, and I'm covering it in silver solder flux, and this is Easy Flow number 2 flux. For those of you who are very much beginners, please bear in mind this is not ordinary soldering. The soldering that most people are used to with a blow lamp or with a soldering iron is soft soldering, and soft soldering is nothing like this at all. For a start, soft solder has a very low melting point, and if I use soft solder, yes, it would attach this tube to the base until I stuck it in the chimney, then the heat from the fire would just melt the soft solder and it would fall apart. This is called silver soldering, or hard soldering, or silver brazing. And for it to be successful, you have to get the work hot enough. It needs to be red before you apply the silver solder. You wait until the flux takes on a watery appearance and just touch a tiny bit of silver solder on the joint, and it flashes around, and that's the job done. When I demonstrate silver soldering, I purposely apply too much silver solder and initially at a lower temperature, so you can see it going to a blob, and then as I raise the temperature, you will then see the blob of silver solder suddenly flash around the joint. After silver soldering components like this, let them cool to black and then quench the part in some water. This doesn't harden the metal or anything like that, but the thermal shock removes some of the flux residue, and of course cools it down to make it so you can handle it. I'm not going to bother painting this. If I wanted to be picky, then I could use some etching primer and paint it to make it look very nice, but because of what it is, it will be perfectly fine like this. The last time I was up at Blackgates Engineering, I did notice that they sell blower kits, and I'm not sure whether you can buy it as a pre-machined kit or whether it's just a casting set. And now I get the chance to use one of my new Barco screwdrivers, and yes, it's a screwdriver, it's not a spanner. I almost forgot. I can definitely test the boiler now because I've put a pressure gauge on it. The most convenient takeoff point for the pressure gauge was on top of the water gauge. It's time now to try the finished blower in the top of the chimney, and it's a good fit, not too tight and not too slack, which will make it very easy to remove the blower once steam is raised and I start to use the steam blower. I extended the cable because the short piece that exited the motor was no good to anyone, and I used a piece of thick silicone rubber fastened to the motor. The silicone rubber serves two purposes. One is heat insulation, and the other is to move the cable away from the boiler. That way the heat of the boiler is unlikely to melt the cable. With the blower on, I'm using a small gas lighter just to show how much suction there is through the firehole door. There's enough draft rushing into the firehole door and up the chimney that the flame is blown out. And that's about it. The boiler now has its own electric blower, which will draw the fire until the steam blower can be operated. Thanks for watching, and I hope you found it useful.